Good afternoon, everyone. A few things before we get started. Please put your devices on silent to minimize any disruptions. All sessions today are being live streamed and recorded and will be available after the session. Please join me in welcoming the session on how to get started with Amazon Aurora DSQL. Please join me in welcoming Peter and Surendar from AWS to the stage.
Thank you. Good afternoon, everyone. First things first, can you hear me? Awesome, thank you very much. So thanks for all joining us for this session, a half-hour breakout session with the title Getting Started with Aurora DSQL. My name is Peter Vandaele. I'm a technical trainer with AWS, and I have the both privilege and honor to be joined by Surendar Monimohan. He's a Senior Database Specialty Solution Architect. It's a much longer title than mine, and he'll be joining us for the second half of this talk. Now, there's Amazon Aurora in that title, right? So I'm going to assume most of you have heard of Aurora, otherwise you would probably not be here. But Aurora is our cloud native relational database, all right? And we've been on a journey basically for the last 10 years, the last decade. And I'm just going to highlight a few of the features we've done, the ones that make sense for what we're going to talk about today. So in 2014, we started with Aurora, MySQL. In 2016, we added multi-region read replica. Now this is going to be interesting because we'll pick that up later on. So read replica are basically instances in your database cluster that are focusing only on read requests. So basically taking away some of the focus on the main or primary instance. Now in 2017 we added Postgres. Again, very important because guess what? Aurora DSQL is Postgres based. 2018 we had serverless, the first version of it. Very important because guess what? DSQL is serverless. We also had global databases for the first time. Again, very important because DSQL will be a global database. 2020 we saw something really interesting, namely that our storage was increased to 128 terabytes. Now, then and now, 128 terabytes of storage is a lot, all right, for a relational database. We are focused, by the way, on transactional databases, not data analytics. So that's a lot, right? That's it. We did away with any limits. So one of the cool things about DSQL is we can scale basically to petabytes if we want to. 2022 we had a second version of our serverless. We kept building on that. And then 2024 at reInvent we had the announcement that Aurora DSQL became available, and actually just 8 days ago it became generally available. So in preview, in reInvent, now generally available. So why did we build Aurora DSQL? We already have Aurora. So we talk with our customers quite a lot, and when we talk to developers, what we noticed, especially those who are building serverless distributed applications, they say, hey, you know what, there's a bit of a mismatch between your offering, especially when it comes to relational databases, and what we need for our distributed serverless applications. Fair enough, in all fairness. Talking to database people, they said, hey, you know what would be really cool, again, in the relational database space, is a global database, active-active. All right. But in general, what we saw as challenges really when you're developing with relational databases was, first of all, resilience. Any downtime, whether it is planned or unplanned, it's going to cost you. Nobody likes that. So we'll definitely try to avoid that one. Second of all, scale. Now we talked about the 128 terabytes. It's not just about, okay, how much can we maximum do, but when we are trying to scale out, typically that again will lead to, you guessed it, downtime. Not good. We want to do something about that. And then finally, ease of use. I mentioned serverless already. That's going to be a big one here because any DBAs in the room? Yes, all right, cool. It's a lot of work to maintain a relational database, right? So the more time we need to put onto the operational side of things, the less we are busy with our application, with our end customers at the end. So try to take that away from you. Now, building a brand new database in under 4 years is not easy, but if we're being really honest, we didn't start from scratch. We had a lot of innovation already going, and we kind of combined what we knew and built on that. Just to give you an idea, the storage. Again, assuming that a lot of you know Aurora, you probably know there's this segregation between the compute and the storage. The storage is a distributed, self-healing layer. Right? We obviously use that and we build on that. Now, when it comes to transactions, we do have a little bit of experience here. Now, you look at things like DynamoDB, our serverless NoSQL key value database, or S3, for example, handling transactions on a massive scale. We've got that, so we use that. We use a technology behind the scenes which is called a journal, which is basically distributed transaction processing. And then, of course, we got serverless compute. Again, I'm kind of hoping this is well known. Lambda and some others have been around for a very long time, so we've built a lot of experience. So we brought that all together to create DSQL for you. Now, each one of those layers also needs to scale independently. So this time I'm going to start at the compute layer. The units there, which are like the instances that you would have in your Aurora cluster at this point, are basically mini Postgres instances. We call them query processors. Right? We'll be using that a lot, and Surendar will talk about that in more detail. So each time you get a query in, any transaction, it gets its own query processor. This is really important. That means that a new transaction coming in cannot take away CPU or block any resources that was currently used by another transaction. And really cool, it is serverless after all. When there's no work, when there's no queries, you're not paying anything. That's kind of serverless 101, isn't it? Now, when it comes to the transactions there, specifically the write transaction, that's where that journal kicks in. So depending on the actual amount of transactions that come in, we will automatically increase the commit logs, the journal will automatically grow. And then when we look at the storage, that's where our read transactions are. You can see write is on the journal level, read transactions push down to storage. We'll have those reads replicas that I mentioned earlier on. They will automatically be added to the storage, and automatically there will be partitioning. It's a little bit akin to what DynamoDB does, for those who know DynamoDB. It partitions, it automatically horizontally scales. And it takes care of that for you. You don't have to do anything. Now, for any developers, if you have your, and let me actually show it here, so you got a little customer VPC there. I'll show it on this side as well. There you go. That's where your application would be running. All right, that's what we just show you there. You got your application. Your application is written for Postgres, for a relational database. Originally with Aurora, you would have one or two endpoints. You would have one cluster endpoint, basically redirects to the writer instance, and then you have a reader endpoint, right? All the reader instances. No more, we've got one endpoint. One endpoint only. You think, so how do you deal with that? Well, remember what I said, read instances are kind of pushed to the bottom, right? To the storage. Those instances, those query processors that we were talking about, well, there's no difference between a writer and a reader anymore. They're all doing the same thing. They're just that mini Postgres thing. So you will have a highly available, one logical database behind that endpoint. You just have to connect to that. By the way, the authentication also has been changed from the classic username password. We're going to an IAM-based authentication as well. So, oops, that's the wrong one. There you go. So basically what we've been doing is breaking apart the monolith. What do I mean with that, with the monolith? Well, again, for those who are familiar with the original architecture of Aurora, you've got the compute part, so the different instances, right? Apart from storage, it still contains a whole bunch of functions that your database engine would do. Well, we broke that further apart into roughly 5, 6 different components, each focusing on one function. So that leads to the following components. Obviously, the front end, that endpoint, which basically functions as a transaction and session router. Transaction comes in, we will redirect it to one of the available query processors, which is the next part. The query processor, that is where Postgres is running, the mini Postgres, whatever is left of it. And again, no write versus read replicas, it's all the same stuff. Next, and Surendar will go into much more detail, but when the query processor receives a query, it also gets a timestamp. And that's going to be really important for our snapshot isolation. See in a minute. But so the adjudicators, the next part of our architecture, are going to make sure that when we are ready to commit to our database, that no changes have been made to the data that we're interested in after we received the query, so that there's no clash. Right? So that's our isolation part. Next, of course, once we get the green light from the adjudicator, we'll bring it into that journal that I already mentioned a few times. Right? So we'll literally commit it to the logs, ready to be written into the database. Now, we might have a bunch of these things going on at the same time. So obviously we need somehow, oops, there you go, to sequence this. The crossbar, it brings together the different journals and then basically dictates the order in which we are going to actually write this to the storage. And the storage, as we already said, takes care of the sharding or the partitioning. So now we have an idea of the why and the what. Surendar will now give us a bit more explanation on the how. So what's going on behind the scenes? Thank you. Cheers, mate.
Thank you, Peter, for that excellent overview. So building on to what Peter has already explained, so we'll go through how these multiple components work in a transaction workflow. So as a developers, so what is a better way to start with understanding how the read and write transactions work in Aurora DSQL between these multiple components? For this, we are going to be using like simple dining recommendation tab. So we're going to be seeing through how the read and write transactions flow through the dining recommendation tab, how these multiple components interact within Aurora DSQL, right? Now, when you open the dining recommendation app and you go and search for some restaurants with the ratings 4 stars and above, so basically behind the scenes, applications take this and run the SQL statements behind the scenes. So for example, in this case, it's going to run select star from restaurants where the rating is greater than 4 stars, right? And let's see how this retransaction translates into Aurora DSQL and how these multiple components come into play. So once a client send a request to the database, it goes to the front end, which is the transaction routers, and then transaction routers, it goes to the query processor. So every connection in DSQL get its own query processor. We have a pool of query processors running in a DSQL, so every connection will get its own query processors. So the no query processor will interact with the other query processor. Each are dedicated to its own connection. So once the query processor get allocated, it goes and gets the timestamp from an EC2 timesync service. This EC2 timesync service, we have been using it for other services as well. It gives a bunch of timestamps to the query processors. The query processor use that as a start of the transactions. So we can, if you think about the other databases, we have LSN, SEN, something like that, right? It's monotonically increasing. This is similar for the query processor as well. So once the query processor gets the timestamps, and then it goes on to the next steps. So in this case, we have multiple components here, right? So the query processor will maintain the shard map. Shard map is basically knows like where the each data resides in the storage nodes. For example, in our case, we have a restaurant table. So we're going to be finding the restaurants which are 4 stars and above. So in this case, it goes and consults the shard maps. On the shard maps, once it consults the shard maps, it goes directly to the storage nodes. Remember, we have other components in here, for example, adjudicator, journals, and crossbar that Peter has explained. None other components come into play. It goes, sends a directly request to the storage nodes, and then storage nodes get the request. Once the request reaches the storage nodes will check whether it has processed all the transaction until at the point of start of this transactions. Once it says like, okay, I processed all these transactions, and then the storage node sends the response back to the query processors. Query processor will get this request and then sends it back to the client, right? So if query processor has to do any merging or anything else, then it kind of do at the query processor layer and then sends it back to the client. In this case, it's just like getting the transactions and then pushing it back to the client, right? Next, let's talk a little bit more than the read transaction, right? Typically, as a SQL developers, when you're writing a code, you start with the basic read transaction, and then you run into a complex transaction. You do some bunch of inserts, selects, and updates into the transaction, right? Let's see how this translates into Aurora DSQL with the multiple components. So building on to the same example that what we previously see, same on the dining recommendation example. So you get the request, and then you first check like restaurants with the top with a rate of 4 stars and higher, and then you go and pick a restaurants, and then you go and add items to the cart. For example, you pick the items that you want, and then you add it to the shopping cart. And once you add to the shopping cart, and then it goes and inserts into the orders table, and then user profile will update those update the orders, and you'll see that, right? And then you go and commit an order. That's how typically you have some transactions work, and that's how you may be using it for some of your applications. Let's see how this translates into Aurora DSQL, right? Similar to our previous example, clients send the request, and then it reaches the front end, and then it allocates the query processor. Once it reaches the query processor will get the timestamp from our EC2 timesync service, and then it started processing those transactions. For example, it runs the selects. For the selects, it directly goes to the storage nodes, fetches the data from the storage nodes. And for the updates, it does a similar thing, because it needs to first read like what is the pre-image, and then reads from the storage, and then it creates the post-image. So it kind of has the both pre-image and post-image in the query processor itself. And whatever the data that you're newly inserting, it's all kept in the query processor itself. And during the commit time, it sends this data to the adjudicator. So adjudicator responsibility is that, hey, I modified these changes. Let's see if any other transaction has modified the similar changes. If adjudicator confirms like, hey, no other transaction has modified these changes for the particular values from the start of this timestamp, then the adjudicator will send this to a journal, and the journal will keep the track of like what are the changes that it made, and then it writes the journal log record. And as soon as it's write to the journals, and then it sends a response back to the client, your transaction is durable and good to go. But you can see the crossbars and the storage, right? So the crossbars responsibility is that it goes and picks the data from the journal, and then pushes to the storage nodes. And the storage nodes responsibility is building from a data pages and kind of creating all these things from there. So that's the overall components work within the DSQL. So the main thing to remember is that for the read transactions, it just talks directly to the storage nodes. No other components come into play. Only during your read-write transactions, it goes to the multiple components, and so on from here. So another thing I want to talk about is that, let's say you're opening a dining recommendations app, you have like hundreds or thousands of customers connecting at the same time, they want to process the data, it wants to process the data at the same time. How the DSQL handles this, right? So DSQL uses a snapshot isolation, which means like it kind of sees whatever the data only after this transaction started, because based on the timestamp, we use based on the timestamp. So the data which has started before, which are not uncommitted, it won't even see this. It only sees whatever the data that is committed after the start of these transactions, right? So you kind of see like few things in here, because you always see the consistent data. You won't see any uncommitted changes. And also within the transaction, if you're making a lot of changes, it can able to read those, and it can able to use those until your transaction get committed. And also the query processor does another thing as well. If you remember from our previous example, the query processor for all the reads and writes, it's all kept locally in the query processor itself. Only during the commit, we send the data across to the adjudicator for other things, right? It kind of holds as a holding tank. So we won't be sending it across for each statement across to different components. We only send it to during the commit time, which means like we are not chit-chatting between different components at the same time, right? So we kind of improve the performance. If you think about if you are doing this in a traditional databases, you kind of take the shared log, or you kind of take an exclusive log, so you can't do like process the other transaction while this is going on. But in the DSQL, we kind of do everything. We check only during the commit time. If there is any other transactions was doing the same, modify the same rows, all we send a response back to the client saying like, hey, there is a conflict. You just need to retry it. That's all you can go from there. Now, DSQL is an active multi-region clusters, right? Let's see what does that mean for your application. So in this case, we have a region. We have two regions. In this US East 1 and US East 2, and we have DSQL clusters set up in these two regions, and we synchronously replicate between these two regions, right? Which means you have a strongly consistent data between those two regions. And here you can see the third region. We call them as a witness region. The witness region it doesn't have all the components that we talked about earlier. It does only the journals. So in this case, when whatever you written in US East 1, it kind of replicated to both of these regions. Either if you get an acknowledgement from any one, we are good to go from there. So we don't need to wait for committed on the both regions, right? And also, each regions get its own endpoint, which means you can if you have an application in US East 1, you can able to perform the reads and writes. And if you have an application in US West 2, you can able to perform the reads and writes in the both region. Imagine your application just thinking like it's a single region, it's doing it. All the DSQL is doing the work for you, right? And also another thing I want to mention is that this is the first relational database in AWS, which kind of designed to provide 5 nines of availability for the workloads. And also, sometimes customers often confuse us with the Aurora global databases that we have. How is it different from Aurora global databases, right? Aurora global databases is an asynchronous replication. The Aurora DSQL is more a synchronous replication, and it's strongly consistent. And also, both regions are equal in DSQL. There is no concept of primary, secondary, or no concept of failing over between one region over the other regions. And also, you can able to perform reads and writes in both regions, right? Even if the one whole region goes down, there is no concept, no data loss, because all the data is synchronized in at least in one region. You might be wondering, hey, this is great. What does that mean for the application? Is there going to be latency across that, right? The team has really built hard to minimize the latency across the regions. The latency comes into play how far out those regions are. For example, if your region is close enough, you'll be laying lesser latency, because we can't change the law of physics. There's only speed of light travel through the fiber optics cables, right? So again, if the regions are close enough, you're going to be seeing lesser latency. Typically, we see like 1 to 1.5 times compared from a single region to the multi-region. So that's what we have seen from our testings. Now, this is how the transaction works, commits works across on the other region, right? Let's say you start a transaction, the selects will work similar to the single region, even though if you have multi-region, because we are not going across the regions to do the reads, right? Even for the inserts and update, we do like as a single region. It could be very fast. It doesn't go across on a multi-region to validate anything. Only during the commit time, we send it across to the region to make sure the transactions are committed on the other regions. Other than that, it kind of works as a single region as it is. Now, let's talk about a little bit on the resiliency part, right? So in this case, we have a multi-region. We have application servers in region A and application servers in region B. We have a load balancer on application servers, and then in front of that, you have a route 53. And then you have Aurora DSQL, which synchronously replicating across between those two regions, right? And whenever your application connects, it goes to the route 53, and then it uses a geo proximity, and then it sends your customers whichever the region they're closer to, right? Nice and good. Now, what happens if the availability zone goes down in one of your region, right? In this case, region A, one of your availability is gone. The region B will work continuously as if nothing has happened, because it doesn't need to know the availability zone gone in region A. It's going to be continue to work as it is. But on region A, your DSQL going to be work as normal, because DSQL span across on multiple availability zone. We can able to detect it within a milliseconds. But as far as your application concerns, maybe until the load balancer detects, hey, there is one availability zone gone, then your application needs to send those to other availabilities, whichever the available availability zones, right? So in this case, you can see some slightly higher latency in that part. But there is nothing happen on the database layer. It kind of works as normal. Now, the other thing I want to talk about is what about if your whole region goes down, right? Even though it's highly unlikely, but there are some reasons where your whole region can go down. We always recommend customers to plan for that, right? For whatever the case. It can be a natural disaster, or it can be a bad deployment, or it can be someone has cut the network cables, or whatever it is, right? So in this case, the region B can operate as normal. Things like nothing has happened, right? But for your, in terms of application, it can able to perform your reads and writes as normal. There is no concept of failing over, because each regions can be independent. It can able to take reads and writes as usual. So your application can transfer all the data to your region B cluster, and it can be able to good to go from there. Now, what about the other scenario? Let's say most of your application, your application stack is working on both regions, but only DSQL fails. What happened in this case, right? Maybe your region B again going to be work as normal as it is, But in region A, maybe your application detects like, hey, I can't able to write to DSQL in the region A. So typically your application, you can able to send the traffic to the region B. It can able to go from there, right? But if your application in region A, when it's trying to connect to the region B, there is going to be latency involved because it needs to send the data to the region B, and then it needs to get the response back and things like that, right? Instead of that, you can able to send whole application traffic to region B, so it can able to operate as normal as it is until the region A comes back up and running. Right, with that, we came to end of this session. So now we're going to be talking about, just to quickly talk about the summary. For that, I'm going to be giving back to Peter. Let's talk about the summary, yeah.
Thank you. Thank you very much for joining us for this short breakout session, just to get you started really with DSQL. So just as a little summary, it's PostgreSQL. That's going to be really important. So I think most of you will be very happy with that. It's serverless, so there is no infrastructure management. That was a really big one with the design of this database. Virtually unlimited scalability. There's no such thing as limitless. I think we all agree on that, but we did our very best to get as close as we could. Very important as well is the multi-region active-active. We just got a really good, a very detailed explanation on that. So I just wanted to add something in there. That's like, we love talking about this unlimited capacity, and it sounds like this is meant for like the biggest of the biggest applications. That's actually not the idea, all right? So yes, it's great that we can go to petabytes, but not then everybody will use petabytes for a transactional database. You can use it from the smallest to the biggest application. It is that serverless, it is that multi-region, which could be useful for smaller applications as well. So just don't think like, ooh, my application is not that big, doesn't matter. And as you emphasized, indeed designed for 5 nines multi-region availability. Now if you do want to get truly started, the QR code here on this slide will bring you straight into the documentation, actually straight into a tutorial where you can get started. Now I can tell you, we ran through this tutorial ourselves, it is ridiculously simple. Like, this sounds like this is quite a lot. If you've ever set up an Aurora database yourself, there's quite a lot of configuration, right? This is going to take 5 minutes. That's it. So try it out. You're going to be surprised, I guarantee you. All right.
All right.
Thank you very much.
Thanks, everyone.
Thank you.
Thank you. Yeah, if you have any questions, we'll be standing behind. Feel free to catch up.